What's poppin', boyos? We are back with another Psychics video with Papa Berg.
What's funny is that when I play this, I always have to figure out where you guys start and where the other ones stop.
Yeah.
Like, you know, because
So you just look for that?
And so, you know, if somebody's in the room,
Yeah.
you know, because that's they hear it, like, what? It's like, yeah. Seriously, just don't say, just don't say. Okay.
Yes, sir.
Okay. Anyway,
So
document.
on number one, it says if one material is more dense than the other, must the atoms of the first be more massive than those of the second? Do you mean massive as in like bigger, or massive as in it has more mass?
Massive as in it has more mass.
Okay, I wasn't sure because I always use massive as in like it's just
Massive.
like real big, and I wasn't sure.
Real big.
I could see how that would have been very confusing. I would have gotten it wrong.
Yeah.
So I get it
Well,
now.
I mean, the answer is the same either way. The explanation just changed a little bit.
No, it's not. No, it's not.
No, because if it's just bigger, then it's different.
Yeah, the
answer's
answer is
different.
I can have a balloon filled with air and a balloon filled with water to the exact same volume. The masses are going to be completely different.
Yeah. So the answer is always going to be no. It just means the density just means tighter together. Don't have to be bigger or heavier.
Okay.
It's close.
Now, let's talk about, make sure everybody's cool, with problem number 14, okay? Because here's what's got to happen on 14. And there's kind of a couple of different ways you can work this problem depending on how fancy you want to get with your algebra, okay? But at the end of the day, this thing is below water. So what are the three forces acting on this thing? Gravity's trying to keep it down, right? Your buoyancy is trying to get it lifted, right?
Tension.
And your tension, okay? And you add all those three together, it should add up to 0, okay? Now, here's the problem. You got to find the buoyant force, okay? This is the problem. To find the buoyant force, what do you have to know?
The density of the liquid, the volume displaced, and
Yeah, but here's the problem. To get your buoyant force, you got the density of the fluid, the volume that is displaced, and G. So it's got the water. Okay, that's no worries. But did I give you the volume of steel? No. So how can you find the volume of the steel? Yeah, because you know the density of steel, which is on your sheet, right, is going to equal mass divided by volume. So if you go to what Kayla said, oh, if I do a little hocus pocus, divide by volume, right, okay, and then divide back by that density. So what you could do here is go, oh, this is going to be the density of the fluid, okay, and then to figure out the volume of the steel, right, that's going to be the mass of the steel divided by the density of the steel times G, right? Okay, that's what you've got. So, you know, now if you want to do old school, you can go through here and you can find the mass of the steel and divide that by the density of the steel, and you can get that number separately, and that's cool. If you wanted to roll that way, you get that number by itself, and you can do that. But here's the other thing, right? So that buoyant force is going to be acting up, that's going to give you this, right? Now if you really wanted to get fancy, so the gravitational force acting downward, right? So that's going to be the mass of the steel times G. So this is where you can do a little bit of factoring if you wanted to. So which one's going to be bigger? The mass of the steel times G, or the buoyant force acting on the steel? Which one's going to be bigger, the weight of the steel or the buoyant force on the steel?
The way.
The weight, because if the weight was bigger, we wouldn't have to lift it up, right? Okay, or excuse me, if the buoyant force was bigger. So if you want to do a little bit of rearranging, you go, oh, this is the mass of the steel times G minus the density of the fluid times the mass of the steel over the density of the steel times G. So if you wanted to, if you wanted to get fancy, you could pull out the mass of the steel times G, okay? In other words, just factor that out of this because that's a common term. Don't have to, but that's just if you wanted to get fancy. then that all factors out, so you'd have like the mass of the steel times G times 1 minus the density of the fluid divided by the density of the steel. So this is just how fancy you want to get with the algebra. It actually makes it a little bit easier to work, so that way you don't have to find the separate calculations. So anyway, that's a little bit fancy. So anyway, so here's the deal. All of your answers on number 14 should be something times 10 to the 5th. On 13E, the percentage that is submerged should be around the legal drinking age. That's an ish. Okay? That's an ish, but it's somewhere around in there. On number 12, a lot of your answers should start with a 4. Not all of them. Okay? But on problem number 12, a lot of your answers should start with a 4. We're good with those. Any questions out of the book?
You said page 435 for problem 22 to 26.
Yeah.
But on 435, it only goes to problem 21. So
Well,
on
it was-
problem 428, are those right ones, like immediately after the.
Yes, whatever chapter that is. I mean, it's just those problems. Yeah. Because where did I have that? 20, yeah, it's just, that's where it's going to start. It's, yeah. We're good? Now, let me give you a hint on problem question 24, okay? Here's what you want to look at on question number 24. You have to pay attention about what they're asking for in terms of like the height that's above, I think they're asking for the height that's above the water line. So on 24 in centimeters, both of your answers should start with a 3. So just keep that in mind. We're good, going once, going twice, sold. Okay. Get those handed in. I don't know, you all had the NHS induction last night, so if that screws you all over and you want to hand it in tomorrow, you can.
Good job joining the cult, everybody.
It was freaky.
I know I don't think it's a cult, but
Oh, yes, it is.
Absolutely.
Excuse me? We had to
I did a paper on cults. NHS was the second cult we talked about.
We had to chant and have candles.
Wait, okay, the candles part, I don't remember what the chanting was.
Well, it's just a pledge.
Yeah, it's a pledge, not a chant, which is still
Yeah,
creepy.
but everybody talking at the same time.
So,
I know, it's still creepy.
Wait, Michael, what is that?
yes, you have a lab, and no, it's not a 2-day lab. Okay?
Oh,
I know this.
so it's 428 instead of 435?
I got really sad.
It's
Because
428
it's a
instead of
3-day
435?
lab.
Oh, it's a 3-day lab?
Okay.
A 3D lab? 3-day lab does that mean that I have no homework for 2 days?
I thought you said a 3D lab. I was like,
Just like it's a war crime.
it's not a 2-day lab.
Oh, war
yeah.
finally, yeah.
Lab.
I was hoping
A
for like
3D
no
lab.
I can't believe you actually thought that's what it
Big
said.
ballad
Well,
of
I was
Buoyancy,
trying to read
Wild
it
Water,
and like
Full World.
it didn't.
We gotta
What
get
did
a
you-
shot out on that title.
That was beautiful.
I was like, is he combining the W and the
Your
A
titles
together?
are
on
the
one
best.
side?
And you know what? It's like, it's capitalized, it's in an
How
acceptable
did you think
font.
that it was a
You
word?
know,
Because
That's
the
what I
L.
mean.
and the A
So
are
what's the
complicated.
one font I can't use?
Comic Sans.
Okay, I'm with you.
Wait, what?
No, you
What?
Comic Sans every single time.
No.
like this for a game. I look forward to your title more
you
than
can't do
the daily pun on the announcements. That's how much I love
Honestly, low-key.
Yeah.
Honestly, low-key, as opposed to honestly high-key?
Yeah.
Yeah.
Okay,
Low keys are better than high keys.
all right.
Base game.
It's like on the low.
Okay.
On the low, I look forward to your
Impressive.
titles than the more than the puns.
Base game.
Which ones had some top shelf titles?
Oh, yes.
You know, those had some top
You
shelf.
said hackers.
Okay.
Every time the ball drops.
Pirates?
Let me go get it.
Not gonna lie, whoever dropped the ruler over here actually scared me.
That was not me.
No, I didn't.
That was, I don't know who that was, but they about ready to get it.
Yeah, I'm gonna find them. I'm gonna find whoever did. Was you?
I'm here with you.
Was you, Jake?
I'm here with you, Andrew. I'm on your side.
Yeah, absolutely. Just like Devin was on my side today.
I have so much trouble. I tried to do this like those.
So what
we
did you
did
say
those
about
a
it?
long time ago, and they're so broken. The only way that you can read my instructions, you have to maximize the program. Like you have to maximize the
Yeah, they put like, because technically ice is like
My
crystalline structure.
favorite part was gonna be drawing
So
like
you're gonna
little
put CR?
creatures using ASCII.
So, but like,
The ASCII chart.
Yeah.
that just
Yeah.
typically like it's
Yeah,
just-
and then like.
But if you have like magnesium ions.
Yeah, dude. I'm gonna make the Dark Souls of 2 base ASCII videos and
No, if it's in chemical equation, it's after, you'd be like,
Oh, right,
in yes.
Honestly, the thing that's gonna take me the longest is making my display.
So he's hitting the wall.
That wasn't random.
That's the thing that's gonna take me the longest.
Yeah, I was gonna start with my battle system before I tried implementing it.
Relevant to the assignment.
No, I have my menu all made. Like I have my menu, I have my menu for my entire program.
Yeah, it actually is, Jason.
I'm just trying to finish up the instructions because my instructions take a little bit longer.
Give an
because
answer.
All the cards I'm listing
Yeah, I
them
know.
Clarify.
So like it'll save time if I list them all. But then,
I don't know.
so I know like my list.
I had to remember to me it's
Dude, like,
no other
I-
options as well as the speed of the things, but no.
Say, dang it.
Yeah, I think I'm like hitting the wall.
I was hoping I could get it done in class, but no, I don't think that's gonna happen.
Yeah, so I'm actually really liking it, so I might work on it outside.
Yeah, I'm gonna work on it at home. I'm just gonna use like
But I
the.
can't do a Google Doc because the Google Doc doesn't format it all.
Oh yeah, I wouldn't use that.
Okay.
Not this direction.
So let me explain what's gonna happen in yonder lab.
Sorry, can you do that?
Yeah.
So what you're gonna do is, and you gotta pay attention to what you're measuring. So the setup that you're gonna have is kind of like what we showed yesterday. You're gonna use a 2.5 Newton scale. Listen to me, you have to use a 2.5 Newton scale, okay? Because do not use 5, do not use 10s, you have to use 2.5 Newtons because those are the most precise scales that we've got. So if the heart and soul of this is over here on, in terms of the data, is over here on page 3, okay? In terms of getting the data. So you're gonna need to make some precise measurements of area of the base, okay, and this will all make sense once you go through. This gets really weird in terms of units, but it all comes out beautifully at the end. So you need the area of the base, so you can take a ruler, measure the base, okay, right? You know what G is, and you're going to have your height, right? Now, your height is going to be the volume that is submerged. So you're going to make 2 readings. Basically, one where it's 1.5, okay? And then the other one where it's going to be 3. So if you look at these measurements, so, and these blocks are all about the same. So here's an aluminum block. So if you look at this, it's like 3 centimeters is basically, for the most part, this thing fully submerged. So basically what you're gonna do is make a mark at the 1.5 centimeter mark, which is gonna be about halfway. So what you're gonna do is you're gonna make a mark and you're gonna submerge it up to that point. Now that's gonna be hard to judge because of your optical distortions going through glass, okay? So you're gonna make a mark, measure that to 1.5. Here's the other way that you could do it. You could either make a mark, or you could take like your measuring device and put that on it when it's in the water until the water goes up to that depth. That's a little bit tough to do because then technically your ruler is displacing some of the water. So it's about as easy if you just, I'm gonna have some Sharpies in there. If you make a mark, if you don't like that, if that's gonna flip you out, then you can use this and put it right beside it and find the depth that way. I don't care. So what you're gonna do is you're gonna get 2 readings. One where you're submerged to 1.5, and then you're gonna fill it up to basically the top, and then you're gonna get another reading. So what should happen to the reading on the scale? Should increase or decrease? Should decrease. So what you're gonna have, and usually with this, you have like more data points, but I found that if you try and go like in centimeters, the deviation is so small, it's really hard to pick up. So that's why I said, okay, we're just gonna have 2 data points on here. But you'll be able to see the trend. So what you're gonna do is you're actually gonna do this on 4 different times. So you're gonna have water, and you've got 2 different types of block. I've got an aluminum block, and I've got a steel block. So this is why with water, you've got 2 different data tables here. So you can have, that one's the steel, like for example. So you can have a beaker that's in there, we're gonna work in there. So you can have a beaker, somehow get that up to that 1.5 centimeter mark with water, and then fill it up to the 3 centimeter mark, get the next reading in water. So then you can do that with the steel. Then when you've got the water, then, and here's the other thing that you can do is just put water in the beaker and then take your ring stand and then, or lower that down into it. Okay, so you don't have, it's like you take water to the block or you take the block to the water. Or you can just have water in there, submerge it down to the 1.5 meter mark, and then lower that hook down to the 3. I don't care how you do it. I don't care if you add the water or you lower the block. Do a combination of the 2. I don't care, okay? Just get the 2 readings. Then, so you can do that with water. Then you're gonna do the exact same thing with methyl alcohol, okay? And I've got a bottle in there, gallon jug in there, labeled AP Chemistry Density Lab. So you can use that methyl alcohol. Now, listen to me, with methyl alcohol, when you get done with the methyl alcohol, dump it back into that jug. Do not wash that stuff down the sink, because I just reuse that methyl alcohol. Because a lot of times, especially if you're going to be making marks with like Sharpies, that methyl alcohol will tend to dissolve that Sharpies, and then the solution is contaminated in terms of using it like in a chemistry lab. So then you're going to do 2 readings. Again, once with methyl alcohol, once with the, methyl alcohol, once with the aluminum, once with the steel. Okay? Good with that. In terms of data, that's the data that you need. So you need to measure the area of the block, and then you're going to get a total of 8 readings, and then you got to draw a bunch of graphs and do a bunch of dimensional analysis, and then a bunch of questions to answer. So let me give you a hint. On the pre-lab, the whole lab's going to make more sense if you kind of go through that pre-lab. And this pre-lab is not going to be done here. This pre-lab, and everybody's doing their own pre-lab, okay? Everybody's doing their own pre-lab, okay? Now, you can talk about it as a group and figure it out. That's cool, okay? But just make sure everybody knows what's going on. So here's the schedule for the rest of the week. We got this lab today. We'll finish up fluids, pressures, Bernoulli principle tomorrow. Kind of. And then that's Wednesday, then we'll review on Thursday, and then this big test of thermodynamics and all that good stuff will be on Friday. Then Monday review, then your overall big written final will be on Tuesday, and then you got a 2-day lab final, and then we'll kick back. So, everybody cool with that? Okay, now, speaking of pressure, so stop that.